Welcome back to our channel, where we will be unraveling the mysteries of the world around us. Today, we are diving into the fascinating realm of the science behind everyday phenomena. Have you ever wondered why certain things happen the way they do? Join us as we explore the scientific explanations behind some common and intriguing phenomena we encounter in our daily lives. Let's get started. Our first phenomenon is the formation of clouds. Have you ever gazed up at the sky and marveled at those fluffy masses? Well, clouds are actually a result of the water cycle and the process of evaporation, condensation, and precipitation. Let's delve deeper into the science behind cloud formation. When the sun heats the Earth's surface, it causes water from oceans, lakes, and rivers to evaporate into the atmosphere. This water vapor, which is in a gaseous state, rises into the air. As the warm air carrying water vapor rises, it encounters cooler temperatures at higher altitudes. The change in temperature causes the water vapor to condense into tiny water droplets or ice crystals around microscopic particles in the air, such as dust or pollutants. These droplets cluster together to form visible clouds. The appearance of clouds can vary depending on their altitude and the amount of water vapor present. For example, high-altitude clouds like cirrus clouds are thin and wispy, composed mainly of ice crystals. Mid-level clouds like altocumulus clouds appear as puffy masses with a combination of water droplets and ice crystals. And low-altitude clouds like stratus clouds are usually gray and blanket-like, formed by water droplets. The shape and density of clouds are influenced by factors like humidity, temperature, and air pressure. Warmer air can hold more moisture, leading to the formation of larger, more towering clouds. Cooler air, on the other hand, tends to create smaller, flatter clouds. Once clouds have formed, they can undergo further transformations. If the air continues to cool, the water droplets within the clouds may freeze, leading to the formation of ice clouds or precipitation in the form of snowflakes or ice pellets. When the droplets or ice crystals within a cloud grow large enough, they eventually fall to the ground as rain, snow, sleet, or hail. Phenomenon number 2. Why do we see rainbows? When sunlight passes through the Earth's atmosphere, it contains all the colors of the visible spectrum: red, orange, yellow, green, blue, indigo, and violet. However, the sunlight appears white to us because all these colors blend together. But when sunlight encounters water droplets in the air, something magical happens. The water droplets act like tiny prisms, bending or refracting the light as it enters and exits the droplets. This bending of light is what causes the separation of colors and creates a rainbow. To form a rainbow, sunlight enters a water droplet and undergoes refraction, causing the light to change direction and split into its component colors. As the light exits the droplet, it undergoes another refraction, further separating the colors. The different colors of light also experience a change in speed as they pass through the water droplet, which causes them to bend at slightly different angles. This bending, or dispersion, leads to the distinct separation of colors in a rainbow. When this dispersed light exits the droplet, it reflects off the inner surface of the droplet and travels to our eyes. Our eyes perceive the different colors of light at different angles, resulting in the iconic semicircular shape of a rainbow. It's important to note that rainbows are always formed in the opposite direction of the sun. This is because the sunlight needs to enter the raindrops and be refracted before reaching our eyes. So, if you're facing the sun with rain or mist behind you, you'll likely see a rainbow in front of you. So, the next time you witness a rainbow, take a moment to appreciate the science behind its formation and the beauty it brings to our lives. Phenomenon number 3. What causes thunder and lightning? Thunderstorms can be both awe-inspiring and a little intimidating. But have you ever wondered what causes the rumbling thunder and the dazzling lightning bolts? In this segment, we'll uncover the science behind thunder and lightning, exploring the electrical charges and the physics that occur within a storm cloud. Thunderstorms are a result of the buildup of electrical charges within a storm cloud. As a thunderstorm forms, strong updrafts and downdrafts within the cloud cause water droplets and ice crystals to collide. During these collisions, electrons are transferred, creating a separation of positive and negative charges within different regions of the cloud. The top region of the cloud tends to accumulate positive charges, while the bottom region accumulates negative charges. This separation of charges creates an electric field within the cloud, with a significant electrical potential difference between the two regions. As the charge separation intensifies, it eventually reaches a point where the electrical potential difference between the cloud and the ground becomes too great to be sustained. This is when lightning occurs. A lightning bolt is a massive discharge of electrical energy. It forms as a channel of ionized air, called a stepped leader, extends from the cloud toward the ground. The stepped leader is invisible to the naked eye and creates a path for the electrical current to follow. Simultaneously, a stream of positive charges, known as a positive leader, may also move upward from tall objects on the ground, such as buildings or trees, reaching towards the negatively charged region in the cloud. When the stepped leader and positive leader meet, a powerful surge of electrical current flows along the path, creating a bright and intense flash of light that we see as lightning. The rapid heating of the air along the lightning channel causes it to expand rapidly, creating shock waves that we hear as thunder. The sound of thunder travels slower than light, so we often see the lightning before we hear the thunder. By counting the seconds between the lightning flash and the thunderclap and using the speed of sound, we can estimate the distance of the lightning strike from our location. So, the next time you witness a thunderstorm, remember that it's all about the electrical charges and the physics within the storm cloud that give rise to the incredible phenomena of thunder and lightning. Now, let's move on to our final phenomenon for today. Phenomenon number 4. How do magnets work? So, what exactly causes magnets to attract or repel certain objects? It all comes down to the properties of atoms and their arrangement within a material. At the atomic level, each atom has negatively charged electrons orbiting around a positively charged nucleus. These moving electrons generate a tiny magnetic field. In most materials, the magnetic fields of the individual atoms cancel each other out, resulting in no net magnetic effect. However, in certain materials known as ferromagnetic materials, like iron, nickel, and cobalt, the atoms align their magnetic fields in a cooperative manner. This alignment creates regions called magnetic domains, where the magnetic fields are in sync and reinforce each other, resulting in a stronger overall magnetic effect. When a magnetic material, such as a bar magnet, is created, the alignment of the magnetic domains is organized in a specific pattern. One end of the magnet is called the North Pole, and the other end is the South Pole. These poles are where the magnetic field lines emerge, North Pole, or converge, South Pole. Now, let's talk about the behavior of magnets when they interact with other magnets or magnetic materials. The general rule is that opposite poles attract each other, while like poles repel. This phenomenon is due to the interaction between the magnetic fields generated by the atoms in each material. When two magnets with different poles are brought close to each other, their magnetic fields interact. The magnetic field lines seek the path of least resistance, resulting in an attractive force pulling the magnets together. On the other hand, when two magnets with the same poles are brought close, their magnetic fields oppose each other, causing a repulsive force that pushes them apart. It's important to note that magnetic fields also have an effect on certain materials, particularly those that contain iron or are made up of ferromagnetic substances. When a magnet is brought near these materials, it can induce a temporary magnetism within them. This phenomenon is known as magnetic induction. The science of magnets finds practical applications in various fields, from everyday objects like refrigerator magnets and compasses to complex devices such as electric motors and generators. Understanding the science behind magnets helps us harness their power for numerous technological advancements. And there you have it, the science behind magnets explained. We hope you enjoyed unraveling the mysteries and learning the scientific explanations behind these captivating events. If you have any suggestions for future topics or any questions about the phenomena we discussed today, please leave them in the comments below. Don't forget to like this video and subscribe to our channel for more intriguing content. Until next time, keep questioning, keep exploring, and keep embracing the wonder of science. Stay curious.